Hello and welcome. In this lesson, we're going to look at the sign of the first derivative for a decreasing function. If the derivative is negative, that means the function is decreasing. Now, we have a graph here, and we are asked what can you say about the function and its derivative on the interval 0 to 1. That's 0 and that's 1. This is your interval between 0 and 1. Your graph between 0 and 1 is this path here, all along this path until this point. This point has an x equals 1 coordinate. So you can see that this graph is a graph of a function decreasing on this interval 0 to 1. You can see that the points, the value of the y is decreasing. Okay, so we say that the function is decreasing on the interval 0, 1, and its derivative is negative, because that's what we say. If f prime is negative, the function is decreasing. Okay, so because this function is decreasing, so we have to get f prime negative. Okay, now the other question is fx equals minus 2x plus 1. Show that this function is decreasing on its domain and graph it. We derive the function. So the derivative is minus 2, as you can see, minus 2x derivative is minus 2, plus 1 is 0. So you can see that derivative is a constant, a negative constant, so it's always negative. On the domain of the function is Orion numbers because it's a linear function or polynomial function. So because the derivative is negative, that means the function is decreasing for all real numbers. And now the graph, we get a straight line like this. That's your line. Y-intercept equal 1, that's from plus 1. And the slope of this line is minus 2. So 1 on the x, 2 down on the y. So this is your graph. So it looks really that it's a graph of a decreasing function. Question 3, fx equals x squared. Show that this function is decreasing for x less or equal than 0. So again, we derive the function and we check when this function is negative. So the derivative is 2x. This is negative for x negative. So the function is decreasing for x less or equal than 0. Okay. The other question is x cubed plus 2x squared. Find the intervals on which this function is decreasing. So we derive the function. We derive the function 3x squared plus 4x. Sorry, here I mean decreasing, so this is a mistype. Okay, so we mean f prime of x equals 3x squared plus 4x, and then we find the roots of these derivatives by factoring. Your roots are 0 and minus 4 over 3. Okay, now the table that shows the sign of the derivative and where the function is increasing, this thing is here. I'll explain this in another video, how to get this table. I'm going to explain it again. The domain of the function is all real numbers, so you put all real numbers here from minus infinity to plus infinity for x, this row, I mean. And then the derivative takes this sign, 0 at each root, at 0 and minus 4 over 3. Between the roots it's negative. Opposite a, which is 3, positive. If this is positive, between roots you put opposite that sign. outside the root exactly the same as the sign of a. Or you can just test one value, for example between minus 4 over 3 and 0, and you get for example for minus 1 you get it negative. That means the sign here is negative, and because the sign here is negative, the function fx is going to be decreasing on this part between minus 4 over 3 and 0. Okay, so we get it decreasing here. Good. Now the function f is decreasing on which interval then? Only on this interval between minus 4 over 3 and 0. Minus 4 over 3 to 0. This is it, and I hope this helps. So remember, if the derivative is negative, the function is decreasing.